Guys, welcome you in the last and final part of alkyl lithium part 3. And as we discussed earlier in initial first part 1, if you revise, we have discussed all the reactions having resemblance with Grignard or not having resemblance with Grignard earlier. And now we are moving towards the next part where preparations of those things we have discussed already, which are resembling with Grignard. Now we are on other side of this. So other side of story is those reactions which are not resembling with Grignard formation, starting from A prime, that is action of ketone. So action of ketone, addition on alpha beta unsaturated ketones, and all the reactions we'll see. Let's start. The first one is addition on ketone, that is A prime, and we'll see why it is different reaction. So I'm picking up a ketone of this type to ensure a lot of steric issues with this compound. And when we try to react this compound with RMGX, where R minus should come and attack on this, we get no reaction, and not to our surprise, because we know that RMGX avoids these kind of situations. At the same place, if we take the same compound and react the same compound with RLi, so what happens? This R can find out the space, can attack on this carbon and come and join on this, so it will become CMe3. CO minus R has joined and CMe3, and at this place we have Li plus. So if you observe the structure, what we have done, RLi is very less affected. RLi is very less affected, or is very less affected by steric issues. That is the understanding. Okay, very less affected by steric hindrance or steric crowding, or we can say steric problems. So it is not affected by steric issues, hence it is capable of attacking here. And later we know that we can make alcohol. If you want H plus or something, H2 is given, you can make it CMe3 COH R CMe3. So that we can definitely do, that's not a problem for us. So that's the secondary part, but the main part is no reaction with Grignard, whereas different reaction. So I hope you understood the first difference between RMGX and RLi roles. Role number 2, B prime. B prime is reactions which are basically addition on alpha beta unsaturated compounds. So note down alpha beta unsaturated ketones or ketone compounds. So what kind of reaction we can expect? Let's say we have pH, CH double bond CH, C double bond OPH, and the same compound reacting first with PHMGX. So PHMGX, generally what happens, PHMGX can attack at this carbon also, can attack here also, and this can move, and again attack is possible. So PHMGX is having both the possibility, either 1,2 or 1,4, and we know that if we keep increasing the size of PHMGX, it will prefer 1,4 as compared to 1,2. But when it comes to RLi, the same question is given with RLi. So let's say I'm just writing the same question, only I'm changing the reagent. In place of PHMGX, which is a Grignard, let's say we bring something like RLi. Then what is the difference going to happen in this question? So we say this time this only picks up attack on C double bond. It attacks here only. So if it attacks here only, or we say, let's say we have PHLi. Okay, if you have problem with RLi, you can say PHLi. Same thing is applicable. It will attack here only. So what is the difference in both the answers? In the previous case, answer could be pH. Now if you attack it here, you can break this bond and this becomes O minus. So we get pH, CHPH, CH double bond CO minus, pH, MgX plus. Whereas in this case it is pH, CH double bond CH, this will attack, so O minus, and you have pH, and pH is joining at this place. Later it can become OH. So this is the same thing. What is the difference? If you observe the difference, the position of double bond has changed in 1,4 attack. Okay, 1 pH comes here, and then this O minus is getting H at this place. It is 1,4 attack. This is 1,2 attack only. So the previous one 1,2 is also possible, but 1,4 is the major answer for B prime. Now after this, the third reaction, which is the differentiating reaction, is reactions on carbon dioxide are different. So if you take carbon dioxide and react with RMgX, so we know that the first attack is possible, and it forms RCO minus double bond O MgX plus, which later with water can become RCOH and double bond O. That we know. But what about if you have C double bond O reacting on RLi? So what can happen? The first attack is like this. So this part is similar, double bond O, and then R is joining here, Li plus we can write as we have written earlier. Now this is stranger, this is a little different. So I'm just using different colors so you can understand this better. Now RLi can again attack. See, this is a carboxylate linkage. Even then RLi is capable of breaking this linkage and attacking here. And what will it do? It will attack and form RCO minus Li plus O minus Li plus, and one more R has joined here. So now we have two R's. And if you give it water, okay, 2H2 or something like that, so it becomes RCOH, which can release water to become ketone. Because we know alpha elimination, 1-1 elimination, we have done these things in elimination. So what's the answer? RC double bond O R. It's a ketone which can be formed. So this is the overall reaction that we understand. How differentiation can be done between the reaction of carbon dioxide and the given compound. The next reaction, which is, we can say D prime, or the fourth differential reaction between what you call RMGX and RLi, is reaction on olefinic double bond. So on double bond, if you talk about, if it is C double bond C, on RMGX you should not expect any answer, but C double bond C with RLi we expect answer, and it is like this. So what it forms is RCC minus kind of thing, or we can say RCC Li thing, if we can write like this. And later this RCC Li can attack on some other unit, okay, of C double bond C, and they can start clubbing like that. And at the end you can just put hydrogen as you required. So RNGX no reaction, but this will do the reaction. And the last reaction where RLi and difference between RLi and RMGX can be talked about is reaction, note down, this is very important reaction, addition on activated carbon atom of aromatic systems. So we will see what is meaning of it. Try to draw pyridine. So in pyridine you will draw like this, okay. In pyridine you try to react PHLi. So what happens? Normally if it is RMGX or PHMGX, it won't affect this thing, but PHLi is capable of coming at this place. So you can say, you can draw like this, and this N part is there. So on this N part you can say this bond which is broken here, this is Li coming up here, and pH is at this place, H is at this place, right? So what we have done, PHLi is directly attacked on this, and if you give HOH, so with HOH what we can expect, we can expect that this will grab Li part and form LiOH and hydrogen gas and give us a compound like N, and this place we get pH. So this kind of compound we can expect, which is called phenyl pyridine. This reaction also differentiate what you call RMGX with other members, or we can say RLi members. So I hope if you summarize the whole discussion starting from RLi reactions like this, we have concluded all three parts of it. So I hope you like these videos. If you liked, don't forget to like, subscribe and share. Like, subscribe, share and refer to many more. Thank you very much.